Okay, so today the topic is probability, and let's start. I don't know, it's not totally physics, but it's math, and this channel will be more like whatever I am interested in. So this is probability. So this will be a full course on probability. I have nothing written down. I do have a note that I made. I will probably put link to it in the description or anything, I don't know. So basically let's start. So the basic theorem of probability is that in a sample space, let's say in the sample space contain all the outcome of an event, then probability of a event that happening is number of outcome in which the event is satisfied by total number of element in the sample space. So that's the basic principle of probability, and more than half of the probability sum are gonna be just recognizing this NA and NS and just applying the formula and nothing else. Like everything is in this one formula. This is very simple. Now when you go a step higher, it becomes a bit different. That is probability of two or more states, like P of A union B, probability of A and B both, or anyone, like A, either A or B or both, so total. So or it can come as probability of A union B union C. Like there are many addition theorems of probability. So all the union, just imagine an Venn diagram. I think I will take here. In the first case, when it is A union B, this is A, this is B, and this is the sample space. Now imagine this sample space, and we need the probability of A union B, means the whole region inside this, like this whole shaded thing we need. Now how can we do that? That is, we can take whole A, P of A, then whole B plus P of B. Then if you see this intersection, this common region is taken twice, for A once, for B twice. So we'll subtract that, minus this common region is A intersection B, so minus P of A intersection B. So you can go the same, exactly same way for I don't know, 3. Let's just say, let's go for A union B union C. P of A union B union C, or any. Let's stick to C only for now, just the basic idea. So let's draw a Venn diagram of A union B union C. Let's see. So yeah, this is A, this is B, this is C. Now we can go similarly, like P of A, let's add P of A plus P of B plus P of C. Now this area is taken in A union B, and also this area is taken in A, also in B. So you have to subtract this area. Then again for this side, this area is taken for A and also for C, and then again for this. So these three we have to cancel. So it's P of A intersection B minus P of B intersection C minus P of C intersection A. Now if you see, we subtracted this, we subtracted this, we subtracted this portion, yeah, this and this. So when we took this part 3 times in A, in B, in C, so we subtracted this common region 3 times only. So there is nothing in this region right now. We did not this equation does not contain the middle region, so we'll just add P of S, that is A intersection B intersection C, and that's the formula. So you do not need to memorize it. In any case, you can just draw this diagram or imagine in your head, and all the formulas will be there. That's basically it. So let's get rid of it. Then we have, oh yeah, then we have, let's say, probability of only A, not B, only A, only. So if we have the Venn diagram like this is A, this is B, A, B, then we have to A only, it cannot be B, so it should be this shaded region. So how can we get this shaded region? Easy. P of A minus this intersection area, that will be P of A intersection B, just like that only. So you can go like this, like in the Venn diagram you will find all the formulas you need. You just need to think a bit, and probability is mainly one of the way of logic. It's completely logic based, so you can basically just go through it, like probability of exactly one thing happening out of many, that will be probability of at least one minus probability of at least two. So basically exactly one is there, and at least one you took, and at least two you took out of the at least one, so the only exact one is there. You can just think about it in the, yeah. Now comes the next part, that is conditional probability. I cannot write that much. Okay. Conditional probability is when something has happened, it's given, then what is the chance of the next this thing happening. Like we know out of a sample space they may be connected or not, but this has happened, and then what is the probability of this happening. So it can be written as P of A by B. That means probability of A when B has already happened. Now the general formula that is used for this is taken as P of A intersection B by P of B, probability of A intersection B by probability of B. But I have seen many people like memorize this formula and blindly apply, but I think a better formula is this one, N of A intersection B by N of B. So this is not the probability but the numbers of item in A intersection B and B. So in this case, whenever you are getting any kind of problem, just think of the number of unit that A intersection B contains. This means this conditional probability P of, just remember this, I think this is better, P of A intersection B, sorry not intersection, oblique B, A when B has already happened, is basically probability of A when B is the sample space. So basically think of this, and actually in this way you can solve almost any, like you do not need the probability formula. But if you wanna ask how did this one and the probability one, you can just divide both by n of s or sample space and you got the probability formula. So that's how this is coming. And basically I think after explaining all this I will probably go to some problems and then we can just try to solve. I don't know if anyone is watching, but I will still try to answer as nicely as I can. So let's see. Conditional probability, there is basically this much only, nothing else is there. You can just think it out mainly. nothing else. I don't think anything else is required in this case. At least I never needed as much as I did probability. And then there is independent event, which can be easily understood by, again, trusty old Venn diagram. In independent event just means that outcome of one is not dependent on another. Let's say we are rolling 2 dice. I do not have dice present. Let's say this 2 are dice. So I am rolling this and I am rolling this. So whatever comes in this does not affect anything that happens in this one. So they are basically 2 independent events that have no correlation with each other. So basically in that case, oh, and always remember, in probability, whenever and is there, like this and this, there will always be some sort of multiplication. Always be some sort of multiplication, and wherever or is there, like this or this, like and is an event is completed, like first this, then from this you can go like this, and or is you can go to the thing from different boxes, like this is or. Whenever there is or, there is some sort of addition there. Just remember it. So intersection is always and. So whenever we say in case of independent event, let's see intersection. So P of, let's say A, let's say B. So whenever P of A intersection B is there, this is basically P of A and B, probability of A and B. So basically just multiply P of A into P of B, and you have the formula. This goes for anything, P of A intersection B intersection C intersection dot dot dot, as long as they are all independent event, it's just gonna be like P of A into P of B into P of C into dot 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 dot. It just goes on, and pretty much that's it in independent events. This is the basic part. I think that's how I think the math goes, but yeah, I will try to solve some after this. Wait, do not go my outlines. Hello darkness, my old friend. Oh, and another thing, if A and B are independent associated with a random experiment, not A and B are also independent, A and not B are also independent, and not A and not B are also independent. Just say that. Okay, then what else is there? Now comes the and. We just did the and case, like P and B. In the A and B we did in independent or dependent whatever event. And is always some sort of multiplication. It's mainly gonna be in independent event, or dependent you can just multiply, like use the basic formula P of A is equal to NA by NS and multiply them, kind of. So you will get that way how to multiply. Okay, so then there comes law of total probability. এত কিছু লিখতে পারি না. Okay, sorry. So law of total probabilities. Let's say there is an outcome. There is an outcome, and there is some events that are mutually exclusive and exhaustive. Mutually exclusive, and let's say this is the sample space. Mutually exclusive and exhaustive is, let's say this A, B, C, D. There is no common region and they totally fill the whole sample space. So this is mutually this is mutually exclusive and exhaustive event. So in case of mutually exclusive and exhaustive event, let's say there is a whole sample space, so that is broken into these three. Let's say this is E1, event 1, this is event 2, this is event 3. So basically the thing is that P of, then let's say event 1, in event 1 there is a probability of A, we need probability of A happening in total. So in E1 there is a total of probability of A happening, P of A1. There is in E2 there is probability of A happening in P of A2, and in E3 there is probability of A happening as P of A3. So then my formula just becomes probability, sorry, one sec, P, okay. So my formula is, here is an AND case. Let's see, when E1 happens and inside that A1 happens, so basically it's gonna be like P of, so P of A total is equal to P of E1 happened, and then in E1 A1 happened, so that's gonna be P of A1 by E1 plus OR case. This is OR case, like they are totally independent paths, so basically it's gonna be plus P of E2. Similarly, how much, what is the probability of this happening, and after that P of A2 is happening, so it's gonna be conditional probability again, P of A2 when E1 is the same, E2 is the sample space, plus, sorry, this shouldn't be A, they are just probability of A, so no need for A1, A2, A3, probability of A in probability of A in E2 by E2 when E2 is the sample space, and then probability of E3 and probability of A when E3 is the sample space, and it goes on like that for any number of events. So basically you just see it like they are taking different roads, they are taking different roads to the same destination, so you just find out the probability of each destination, each road, and then just add them as their OR, and in the each specific road there is an AND case, like first E1 happened, then in E1 P of A happened, so you go there, then E2 happened, then in A2 P of A happened, so you go there, then E3 happens, then in E3 happens, so you go there. So those are AND case are multiplication, OR case are addition. So basically that's the law of total probability. And the last point is Bayes theorem. That's gonna be a lot dependent on this one. So wait a minute, I don't know how this is going. I'm basically blindsided. Am I even visible? I don't know. I'm just speaking for how long yet? Holy shit, it's 20 minutes. Okay, so now Bayes theorem. I'm not writing. Now this is gonna be an extension of the previous law of total probability. So in total probability we had to find from a different number of event with each different of P of A we had to find the whole probability of A from number of different mutually exclusive and exhaustive events. But in Bayes theorem we are gonna do the reverse, like there will be given a probability of A will be given like at a whole, then we have to know that what is the probability of that this A is coming from a specific event. So here also think of the basic formula of probability, P of Na by Ns. That's all there is, because this is gonna be something like this. So P that E1 was the event, given A has happened, so P of E1 by A, there's gonna be my path, like this path. Let's say this is E1 and this is A, so this is one path, so this is gonna be the NA, which event is in favor. So this whole event is in favor, so we remember the contribution of this in the previous one. So this is gonna be P of E1, and under it the probability of A is, so P of A when E1 is the sample space, by summation. Basically by is the total probability of A. Now what is the total probability of A? We get that from the previous formula of what was that, law of total probability. I'm not good with names or blah 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 many things. Okay, so this is like we showed previously, this is P of E1, P of A when E1 is the sample space, plus P of E2 into P of A when E2 is the sample space, plus dot 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 this. So this whole is this part, which can be summarized as summation of I equals to 1 to n P of EI into P of A by E I don't know if it's visible, but it's A by EI. Okay, my handwriting is shit, so bear with me. So basically that's the base theorem. So it's P of, so I have also written here P of E1, that the experiment in which E1 is the experiment, probability of E1 is the experiment in which the given event happened, is probability of event, the given event, into the probability of A in the event. When A in the event, like when the event is the sample space, by total probability of A happening out of all the possibility. So that's base theorem. So the video is kinda getting long, I think. How much? 22 minutes. Let's take it to 30 minutes, I don't care. So let's solve some problems. I don't know, like I'm not even gonna think of the formulas or anything. It's gonna be mainly like the basic, as much as basic I can think. So I'm gonna try to be like that. Let's take 12. I don't know, I'm taking random, so I might not be able to do actually, but I'll still try. Oh shit, sorry, I fucked up my writing. Shit. Okay, sorry. Skip that part. Okay, so let's take anyone. Random, I think 12. Okay, assume each child born is equally likely to be a girl of a boy. So P of boy is half, P of girl is half. If the family has two children, what is the conditional probability that both are girls given the youngest is a girl? First is, what is the probability of both are girl given the youngest is a girl? So if we already have one girl, so there is one possibility. There are two there are two child. So for C1, let's say child 1, child 2. Okay, no need to number. This can be, first one is girl, it's a given. So the sample space is only to G only, girl only. Then next this one can be girl or a boy. So we have to find the probability that both are girl when the youngest is a girl. So the youngest, let's say C1, is a girl. So probability of girl when C1 is girl, it's given, is number of event in which this is applicable. So we see here it is applicable, both are curl. So it's 1 by total number of event in when remember the conditional probability P of A in the sample space when the sample space is the given probability, the given sample space, like given condition. So here the given condition is youngest is a girl, so along that there are two possibilities, so it's gonna be half, like these two are the total sample space and this one is only the event that's happening. So that's a thing. I think that's easy. It's kind of like conditional probability, but you don't even have to think about the conditional probability, you just need to do the sum. Let's see. Okay, this one is good. Number 10. A black and a red dice, black dice and a red dice is rolled. Now they said find the conditional probability. Do not even think about it, you will just do it now only normally. Obtaining a sum greater than 9. Conditional probability of obtaining a sum greater than 9 given that the black die resulted a 5. So black die is given a 5. Conditional probability that the total sum is more than 9. So total sum more than 9 is possible. Let's see, you can do this in head, like when B is a single one, R is anything it can be. So there are, since it's a die, there are 6 possible, but we'll just try. So it's gonna be my 5 1, 5 2, 5 3, 5 4, 5 5 and 5 6. So there are 6 possibilities of the given event. So this is gonna be my sample space for this, because this already given. So now we have to see which one checks up in according to the condition, which one will be the P of A, so, or NA. So red has to be, for it to be, it was a sum greater than 9. If it's greater than 9, then it has to be 10 or 11. So there are 2 possibilities that satisfy the event. So P of sum greater than 9 by when B is 5 is NA, N of event which satisfies the given condition. So this is 2 by total number of event that B has satisfied, the given condition has satisfied, that is 6. So this is gonna be 1/3. So that's basically gonna be whole conditional probability, nothing else is there. Kind of everything goes around in the same thing. Just think of the sample space, which is the sample space when the given condition is applied. No, do not take the whole sample space, that will be a problematic. Take the sample space which is in which the given condition has been approved. So this is the black column and this is 5 always. If I take all 36, it's gonna be a huge mess to do. So just think of it as this, you get this sample space, and out of this which one satisfies the next condition which we has to find out. So just take it, and everything is gonna be around the same only as far as I know. Now everything I am saying is as far as I know. I am just basically just a student, so I don't know anything, so it's up to you. Okay, let's see, let's go next. I don't know. Okay, this is a good one. A die is tossed thrice. Find the probability. Dice is tossed 3 times. Find the probability of getting an odd number at least once. So odd at least once. Now we can find odd at least once by 1 odd and 2 even. Like there are D1, D2, D3, let's say 3 rows. So it can be 1 odd, 2 even, or 2 odd, 1 even. Like you can go like this, but this is time consuming. Rather you can do in another simple way. Odd comes at least once is 1 minus probability of all even, because when those are not all even, at least one are odd. So we can just basically input this formula. This will be a hell lot easier. So P of all even, and since dice roll are independent, they do not care which the previous dice has rolled, so this will be treated as independent event. There is no correlation in the sample space. So just go like this. Probability of all event in D1, P of all even in D1 is gonna be 1, sorry, let's say 3 by 6, because there are 3 even numbers and there are total 6 numbers of numbers available in a die. So 3 over 6 or 1 by 3. Similarly, in second case also it's gonna be 1 by 3, because still the same, it's an even 1 by 3 into 1 by 3. Now this whole is subtracted from 1 because we have to find P of at least one odd. So 1 minus this, so it's 1 minus 327. So 1 by 27, so it's basically 26 by 27, done. You don't even have to input any formula, just think about it, think about the sample space, and it's all done. Probability is mainly thinking about the sample space and the event. Basically the main formula is only this only, P of A N A by NS. The only trick is to find what's NA and NS. If you just find that, and all the probabilities are reduced to only this one kind of problem. So okay, let's see this one. Probability of solving a specific problem independently. This is a good word, independently. So no problem in sample space merging together. A probability of A solving is given to be half. Probability of B solving is given to be 1/3. So the question is, what is find the probability if they both try to solve the problem independently? Find the probability that the problem is solved. If the problem is solved like the previous one, this one can be solved like problem is solved is equal to problem A solved but B did not solve, plus problem B solved, A did not solve, plus they both solved. Hell lot of work, but we can just do 1 minus probability of problem not solved. Now this is just one case in which they both fail. So we have to find P of A bar. Since A is solved, so A bar is not solved, which is 1 minus half is equal to half, and P of B bar, which is 1 minus 1 by 3 is equal to 2 by 3. So we find A half and B half. So we have to find P of not solved, P of solved. So P solved is equal to 1 minus P of not solved. P of not solved is when A is also not solved. So P of not solved should be P of A bar into P of B bar. Since these are independent, so they are just multiply and not solved. This is an AND case. A also not solved, B also not solved. A and B both not solved, so P of A bar into P of B bar. So this is gonna be half into 2 by 3. So 2 cut, 1 by 1 by 1 minus 1 by 3 is 2 by 3. This is the probability of P solved. Remember the basic things, and also always find to see patterns like this, in which if you just 1 minus do something, then it will be a hell lot easier to calculate rather than doing 3 or 4 different cases. Okay, let's see. Now erase again. This was conditional. No, this is multiplicative probability. Let's go to the next chapter. This is quite fun actually, gotta say. Where the hell are you, man? Okay, yeah, I got an problem. Well, let's do the first one only. I don't know. An urn contains 5 red and 5 black balls. The ball is drawn at random. The color is noted and returned to the urn. So ball is drawn and noted and returned back to the urn, and the color is noted. And moreover, 2 additional ball of color are drawn and put in the urn. Then the ball is drawn at random. What is the probability that second ball is red? Moreover, 2 additional balls of color are drawn and put in the urn. Then a ball is drawn at random. Find the probability that the second ball is red. Probability that the second ball is red. Even I have to think. I do not know. I'm just taking random answer. So the probability of a second ball is red. If I do any mistake, just tell me in the comments. I will probably rectify. I cannot rectify the video, but I will give it in description or in comments. I will just say everything, like where I went wrong. It will be probably in description. Now there are actually total 4 balls. Now the second, okay, this is just a case, sorry, I was thinking too much. This is just a case of that independent event. The second ball is red. Since I am taking out the ball, noting and putting back, so the initial sample space is never changing. See, the sample space is never changing. So that means the first ball, whatever the first ball was, whatever the third ball was, those all are independent of the probability of the second ball being red. So the probability of second ball being red will just be red. 5 out of total, that is 10, is equal to that much only. Do not think too much, like I was in this case. Actually I was thinking too much, so I got problematic. I'm seeing questions. Card of 52. Pack of 52 card is lost from the remaining cards. Drawn of 1. Okay, this one is an extensive word problem, but it just go through the words and you will be able to do it. Let's see. A manufacturer has 3 machine operators, A, B and C. The first operator produces defective is 1%, B produces defective 5% defective, C produces 7% defective, and the time for which they do the job is 50%, 30%, 20%. See, they are all adding up to 100%, so they are mutually exhaustive event. So we are going to apply the Peirce formula, but do not even think about it. So now the question asks, a defective item is produced. Find the probability that it was produced by A. A defective item was produced and find the probability that it was produced by A. Now just go by the Peirce formula. Imagine in mind what that is. P that defective is from P that A is the manufacturer when the thing is defective. So P of A, so basically that's gonna be N of A, like in the previous year. Now it's gonna be P of A into P of defective happening in A. by p of whole defect happening and blah 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 blah. So we can just go like previously we saw here. 50% of the time A is running, that means the probability of A being run at that time is 50 by 100 is equal to half, just simple math, or 0.5 you can say. I think 0.5 is better. So probability of A is 0.5 into, it produces only defective only 1% of the time, that is probability of defective when A is the sample space. So into 0.01 by total probability of defective happening, that will be first probability of A, that is 0.5 into doing is 0.01 plus probability of B. Probability of B, since it is 30% of the time, so it's gonna be 0.3 into 5% defective, so 0.05 plus C, which is 20% of the time, so 0.2 into 7% of them are defective, so 0.07. so that goes, if you calculate, you will get the whole probability of that the defective item is from A. That's the Bayes formula application. I think I did almost nearly all the sorts of application. Let's see. Wait a minute. What the hell did they? Okay. This video is getting too long, so last I'll show one last type of problem and then I'm gonna stop. Okay, so the last type of problem is, let's say there are two guys, A and B. Now they get into a bet, that is they will roll a coin, that is, let's say they will flip a coin. This might be going out too much, so A, B, flip, and whoever wins, whoever gets head will win. Now you are said to find the probability of A win. Now when does A win? So basically this is if probability of A giving H, probability of A giving H, this is one probability, but A might not give H, so probability intersection, this is intersection, since this is an AND case, this is not an OR. Like if this happens, or wait a minute, I think I'm messing up. Oh no, this is an OR case. Like sorry, even I mess up all the time. So probability of head happening, if head happens first time only, then A just wins. If not, or A gives H, so probability of A giving tail into B cannot win, so probability of B has to give tail into probability of A giving H. Like the second, first A flipped got tail, then B flipped got tail, then A flipped got head. Then similarly you can go like for the third case, probability of A T into probability of B T into probability of A T into probability of B T into probability of A H. So now if you see the probability of H is half, probability of tail is half, so you can go basically like this is, you can see a GP appearing, that is this is half plus, let's take this independent, so this is gonna be 1 by 2 half squared into half plus this is independent, this is 4 times, so half to the power 4 into half. You see A, this is A and this is the R. R is half square by 1 by 4 or 1 by 4. Then we can just apply equal to a, that is half by 1 minus r is 1 by 4, so you can just apply half by 1 minus 1 by 4 and we evaluate. That gives us the probability that a wins. This can also go like with dice and anything. I think that's most of the probability. If there is any point which was vague or problematic, tell me. Probably nobody has even got to hear. I don't think anybody is going to get to hear, but still, this was actually really good. Okay, my plan is working. This is very good. Thank you. So I've been there for 45 minutes and 38 seconds. So tata, bye bye and good night.